Now we're going to be graphing systems of linear inequalities, which means we're going to see the greater than, less than symbols, or greater than or equal to, less than or equal to. So if we were just graphing linear equations, we would just graph the line and we're done with it. When we're graphing inequalities, there are two extra things we need to worry about. One is whether we're drawing with a solid line, which we would do if we have a less than or equal to or greater than or equal to symbol, or whether we're drawing these with a dotted line, which we do with just less than or greater than symbols. So that's the first choice we need to make. And then for shading, I talk about shading up here in the box, but I broke it down here as well. There are two methods that you could use for shading. The first method, I'm just naming them method 1 and method 2. So shading, method 1, first you solve the inequality for y, remembering to flip the inequality if you divide by a negative number when you're solving. And then you look at your inequality symbol after solving for y. For greater than or equal to, you shade up above your line. Less than or equal to, you shade down below your line. So that's the first method. The other one is the test point method. So for this test point method, you don't necessarily need to solve your inequalities for y, but you would graph them using their, either the solid or dashed line, solid or dotted line. And then for each inequality, you're going to plug in a test point. Typically, this will be 0, 0 into the original inequality. Plugging 0, 0 in, if it creates a true statement, then you're going to shade from that line toward 0, 0. If plugging in 0, 0 creates a false statement, then you're going to shade away from 0, 0 from that line. So I'll show you both of these methods as we're graphing. So in number 1 and 2, I'm just graphing a single inequality. So for example, for number 1, I'll graph y greater than or equal to x. And if I were graphing y equals x, right, just the equation, I could imagine this as y equals x plus 0. So the y-intercept is 0, 0. The slope is 1 over 1. So up 1 to the right 1, up 1 to the right 1. Or equivalently, we could go down 1 as long as we match it with to the left 1. When I plot this, I'm going to draw this with a solid line because of that greater than or equal to inequality. So that's what my solid line looks like. And then I need to determine my shading. So there are two ways that we could determine the shading. Notice that this is already solved for y, meaning y is already by itself on one side of the inequality. So it's already solved for y. So now I'm going to look at the type of inequality symbol I have. It's y greater than or equal to x. So you see if you have a greater than or equal to symbol, you shade up above the line. So I'm going to choose shading up here. Okay, so I draw my solid line and then I shade up above my line based on that inequality symbol. So that's how I made my determination. Now, if I were using the second method where I'm using this test point method, so if I want to use method 2 where I find a test point, usually I use 0, 0. Usually I would use 0, 0, but notice that 0, 0 falls on my line, so it's actually not a good candidate as a test point. If your line goes through 0, 0, don't use 0, 0 as a test point. Use any other point. So maybe you could use, I don't know, 3, 0. Doesn't matter, but just like any other point that doesn't fall on the line. So how about we use 3, 0 as our test point? Okay, so if we use 3, 0, our inequality y greater than or equal to x now becomes 0 is greater than or equal to 3. That's a false statement, so I'm going to shade away from that test point 3, 0. Okay, so pretend like I hadn't shaded anything yet. I'm just going to erase this quickly. So here's my test point 3, 0, but I want to shade away on the opposite side of 3, 0. So again, that will put my shading up above the line, right? So I don't shade toward 3, 0, I shade up away from 3, 0. And I just want to point out, you could have picked a different test point here as well. So instead of 3, 0, maybe you picked negative 4, 0. Okay, so let's say we picked negative 4, 0. So plugging that into y greater than or equal to x, we would have 0 is greater than or equal to negative 4. For this ordered pair, now we have a true statement. So we want to shade toward our test point, negative 4, 0. And we did that, right? We have shading at negative 4, 0. We shaded toward that test point. So your test point will typically be 0, 0, but even if it's something else, plug that in, see if it's a true or false statement, and then either shade toward that point if it's true, or shade away from that point if the statement is false. So that's how you use that shading method with the test point. I personally prefer this first shading method where you solve for y. So typically that'll be what I use, but I'll do one more example with the test point just to show you guys. Okay, so for number 2, we have the inequality y greater than or equal to negative 2x plus 3. So just pretending for a second that this is the equation y equals negative 2x plus 3. That goes through the y-intercept 0, 3. Then I have my slope of negative 2, so down 2 and to the right 1. Down 2 and to the right 1, and I'll plot a few more of these just to make it easier to draw my line. I could also go up 2 and then to the left 1. All right, so drawing this, I'm again going to draw this using a solid line because I have greater than or equal to for my inequality symbol. So there's my solid line. And then I need to determine my shading. So I have my greater than or equal to inequality. So for shading, what I consider to be the easier method is because it's greater than or equal to, I'm going to shade up above my line. Shade up above my line. So that's going to be up here, right? And as these get steeper, it might get a little confusing, but always shade just toward the up arrow on the y-axis, right? That's always where up is. Up is where the up arrow is. All right, if I wanted to use a test point instead, here 0, 0 will be a really good candidate because it's not on your line. So if I use a test point 0, 0, I would take my inequality, y greater than or equal to negative 2x plus 3, and replace that with 0 for y greater than or equal to negative 2 times 0 plus 3, which is 0 greater than or equal to 0 plus 3. This is a false statement. 0 greater than or equal to 3 is false. So I would want my shading to be away from 0, 0. And it is, right? I don't shade where I see 0, 0. I shade on the other side of the line. So 0, 0 is not shaded because it's not one of my solutions. Okay? So hopefully this is a refresher. This should be a review for you. In this system, we're going to be combining those two. So we've got y greater than or equal to x and y greater than or equal to negative 2x plus 3. We want to graph that system of inequalities on the same xy axis. So if we're doing that, and again this should be still a refresher, we would graph using solid lines in both cases. We'd graph our solid line at y equals x, our solid line at y equals negative 2x plus 3, so that was this guy. And then we would determine our shading individually for each one. So for our top inequality, y greater than or equal to x, I'm going to shade up above that solid line. So there's y greater than or equal to x, and I would just lightly shade for now up above that line. For my second inequality, y greater than or equal to negative 2x plus 3, again, I'm going to shade above that solid line as well. So I'm going to lightly shade above my yellow line. And my overall final answer is where the shading overlaps. So you can see down at the bottom here, there's no shading. That's not a contender at all. Over here to the left, I only see blue shading. So I'm going to get rid of that. That's not part of my final answer. To the right is just this yellow or orange shading. So I'm going to get rid of that. That's not my final answer. So what is included in my final answer is this upper region here, where I see both my orangish and my blue shading, right? So the two solid lines, which I accidentally erased this one. So my solid lines and then that overall overlapping shaded region. So the overlap and shading is where you shade for that system of inequalities. Okay, so applying that, if we take a look at number 3, it says solve each system of inequalities. So again, I like to use the method where I solve for y first and then use the inequality to tell me what to do. If you want to use the test point method for shading, that's fine as well. Our graphs should look the same. So for number 3, I'm going to start by solving for y for the first inequality. So I have 2y greater than or equal to negative 3x minus 2. Divide all the way across by positive 2. So y greater than or equal to negative 3 halves x minus 1. So that's my first inequality. Here's 0, negative 1, my y-intercept, and then my slope of negative 3 over 2. So down 1, 2, 3, and to the right 2. Or equivalently, up 1, 2, 3, and to the left 2. Up 1, 2, 3, and then to the left 2. Puts me right about there. I'm going to graph this using a solid line because it's greater than or equal to. And when I shade, I'm going to shade above because of this greater than or equal to inequality. So shade up above the line. And I'm just going to do this really lightly. And you should shade in the same direction even if you use the test point method. All right, second inequality. Subtract x from both sides. This gives me negative 2y greater than or equal to negative x plus 2. Now I'm dividing by negative 2 all the way across. And notice that because I'm dividing by a negative, I need to flip my inequality. So I get y and then less than or equal to positive 1/2 x and then minus 1. So again, I have 0, negative 1 as my y-intercept, slope of 1/2, so up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. I'm going to graph this because of my inequality symbol using a solid line. So there's my solid line passing through those points. And then I'm also going to shade down below. I'm going to shade below this yellow line because I have less than or equal to after solving for y. So I'm going to shade lightly below my yellow line. And let's see what we're left with. So I have my two solid lines. Out to the far left, there's no shading at all. Up top, I only see blue shading, so I'm just going to get rid of that. Okay, I don't need that. Down below, I only see yellow shading, but no blue shading. So where the shading overlaps is over here to the right. So this area over here to the right is where I see the overlap in shading colors. So my two solid lines and then that shaded region where the overlap occurs, that's my system of inequalities here. And what this means, by the way, is if you pick any point in that shaded region or on the solid line, so 5, negative 3, for example, 5, negative 3, if you plug 5, negative 3 into the top and bottom inequalities, you'll get a true statement for each one. When you plug in any point, including 5, negative 3, any point that falls in this shaded region. So any of these will create true statements. And any point that falls along either of these solid lines would also create a true statement when you plug them into either inequality. So graphically, that's what that solution means. All right, for number 4, x plus y greater than 3. Let's go ahead and graph that. First, I'll solve it for y. So this gives me y greater than negative x plus 3. My y-intercept is 0, 3. I'm going to graph this using a dotted line because of that greater than or equal to inequality. So 0, 3, and then down one to the right one, down one to the right one, or up one to the left one. So I'm going to graph this using my dotted or dashed line. And then because it's greater than or equal to, I'm going to lightly shade up above that line. So just really lightly in purple for now. All right, so let's take a look at x greater than 2. Now, ignoring the inequality for a second, if I had x equals 2, that would be a vertical line, right? There's no y, there's just my x variable. So if I'm graphing this, because of the greater than inequality, I'm going to use a dotted or dashed line. So let me go ahead and at least graph the dotted line. Okay, so there we go. Now for vertical lines, I obviously can't graph above or below a vertical line because it's vertical. It goes all the way up and all the way down. But I could graph to the left or right of a vertical line. And let's think about what these inequalities mean, right? So I want to graph where x is greater than 2. X is greater than 2 if x is 3, or if x is 6, or if x is 10, right? So I want to graph out to the right toward greater x values. I don't want to graph toward x equals -3 because that's less than 2. I don't want to graph toward x equals -5 because that's less than 2. So if I have a greater than or equal to inequality, in this case I have greater than, I'm going to shade to the right. So I'm going to shade to the right for this vertical line. So I'm going to lightly shade going to the right of that dashed vertical line, and then we'll see where the overlap occurs. So for my final answer, it's those two dotted lines. Those are both part of my solution. Now on the far left, there's no shading at all. In this upper region, I only see purple shading, so I'm just going to erase that because that's not where the shading is overlapping. Down here in the bottom, I only see that orange shading, so I'm going to get rid of that because there's no overlap in colors. But I do see an overlap out here to the right. So over here, and then over here. This is where I see both orange and purple shading. So I'm going to go ahead and darken this in. This is my overall final shaded region. So the two dashed lines and then that overall shaded region.